everyone. In this video, we're going to talk about the law of sine and cosines. Now, this will use sine and cosine, but whenever we normally talk about trig functions, they only apply to right triangles. Okay, if you don't have a right triangle, then you can't use a trig function. But the unique thing about the law of sines and cosines is that you can actually use these two laws to solve triangles that are not right. So first up, we have law of sines. Now, the law of sines, as you can see, is a proportion. You have the sine of an angle over its side is set equal to the sine of another angle over its side. And you see this right here where we have sine of A over A is equal to the sine of B over B, sine of C over C. Now, something I want you to notice about these is that we name our sides based on where the angle is. So if here's angle B, side B is directly across. Okay? The sides are always going to be across from their angle, and that's the point. Here's A, there's side A. Now, we use law of sines whenever we have a pair of information. So, if I were just to come up with a random example from this picture, if I had angle B and side B, and then I had angle C, well, I could set this up and I could solve for side C. Because whenever we have a proportion or any given equation, all we need is 3 pieces and we can solve for the 4th. And that's what law of sines is. You start off with a pair of information, an angle and its side, and then another angle or another side, and you solve for the other piece in the pair. Now let's go ahead and solve a few problems. Okay, this one. So first off, I'm going to orient myself and look for my pair. Here I have angle A and side A. And then I have angle C, and sure enough, I'm looking for side C. So this is, in fact, law of sines. So I'm going to set this up as sine of 97 over 16 is equal to the sine of 21 over x. After this, it's proportion. We can solve those. I'm going to cross multiply. I'll change colors. I'm going to cross multiply, and I have 16 times the sine of 21 is equal to x times the sine of 97. Okay, this is x times sine. So to get x by itself, I'm going to divide by sine of 97 from both sides. Cancels over there. And finally, I have 16 sine of 21 over the sine of 97. This is calculator ready form. Now, if you have a Desmos or a TI, then you can handle these kinds of fractions fairly easily. If you don't, then you just have to break it down into pieces. If you have a TI 30, or maybe even, I forget the brand name, but it's not a TI, then it might just be easier for you to get the decimal of the numerator and the decimal of the denominator and divide from there. So, depending on your calculator, you got to play around with the interface, but just see what you got and what's your best bet. Answer is 5.8. Why 5.8? Because it's said to round to the nearest tenth. If you did find the decimal of the numerator and the decimal of the denominator, make sure you stay to the 4th decimal place all during your work. Okay, let's go to this one. Now in this one, first off, let's check and see if it is indeed something we can use. So here I have H, and it is across from its angle, or its side. And then my other side length right here, 10, well, we don't know that angle. Okay, we have 73, but that's not helpful to us at the moment. However, even if we don't have angle K, we can find it. We can find it because all the angles have to add up to 180. So I'm going to do 45 plus 73. Okay, so I got 45 plus, and that's 118. So I have 180 minus 118, and that is going to be 62. So 62 right here, and now I have completed my proportion. I have both angles and I have a side. So here we go. I have the sine of 45 over x is equal to the sine of 62 over 10. And now all we got to do is cross multiply. So 10 sine of 45 is equal to x times the sine of 62. Divide from both sides. Whoops, 52. And you have 10 times the sine of 45 divided by the sine of 62. This is equal to x. This is your calculator-ready example. Go ahead and plug it in the calculator and see what you got. Hopefully, you ended up with x is equal to 8. Now, there is a bit of change behind it, but again, we're rounding to the 10th, so we can just go ahead and stop there. And now it's your turn. Do these two problems. The video is going to pause. When it plays again, you'll see the answer. And here are your answers. How'd you do? If you have any questions, make sure you put a mark by it so you can ask me next time in class. And in the meantime, let's keep going. All right, now we're on to law of cosines. Now, the important part about this slide is these equations right here. Let's make sure you have the equations and the picture. Now, law of cosines is neat because despite there being 3 equations, they follow the exact same pattern. Okay? And what I mean by this is that whatever side length is up front, that's the angle in the back. And then the other sides are in the middle. So it doesn't matter what you're trying to find. If you can remember that the side length in the front is the angle in the back, then you can make any of these equations. Or you can memorize them. Your choice. Now, you use law of cosines whenever you don't have a pair. So in law of sines, we would have an angle and its opposite side. Or we would have a side and its opposite angle. We at least had a pair somewhere in there. Law of cosines is when you don't have that pair. Let's say you have angle B, but then you're given sides A and C. Okay, well, you don't have enough information to find either another angle or to get to the side of B. And so that's where law of cosines comes in, when you don't have a pair. Let's do some problems. All right, now here we go. On this first one, notice, just like I said, we have an angle, but we don't have another angle, so we can't put together proportion. Now we're going to go into the law of cosines. So I am solving for this side right here. So that's going to go up front, x squared is equal to my other two sides. 9 squared plus 11 squared minus 2 times 9 times 11 cosine of 28. And if you forgot, I'm just going off of the first one because the pattern for all of these is the exact same. Now, the nice thing about this problem is x is already almost isolated. All you have to do is just take the square root of both sides. So I have x is equal to the square root of everything all over again. Now, as I'm writing this, whatever you do, don't get rid of those first two squares, 9 squared and 11 squared. The addition prevents you from doing that. This, however, is calculator ready, so you can just take this expression and plug it straight on in the calculator, which would give you x is equal to 5.2 as your final answer. Now, if ever you had an error, go back and do it piece by piece. My favorite way to break this up is to do this section first, then this section, and then the cosine of the angle last. So I break up into 3 different parts. This is if I'm ever using a calculator that's not a TI or a Desmos, where I need to do it in smaller chunks. I do these 3 chunks. That way, if there is an error somewhere along the lines, I know where it came from. All right, this next one. I have all 3 sides, but I don't have this angle here, angle M. So since I'm looking for angle M, side M is the one that's going to go out front. So it's going to be 8 squared is equal to 3 squared plus 6 squared minus 2 times 3 times 6 cosine, run out of room, but there it is, cosine of M. Now, because the variable is all the way over here, we got to do some work to get it in calculator ready form. So let's simplify. This is 64 is equal to 9 plus 36. 9 is 45. Minus negative 2 times 3 times 6 is negative 36 cosine of M. Now, small warning. Whatever you do not combine 45 and negative 36. This is multiplication right here. It's negative 36 times cosine of M. Just like you can't do 2 plus 3x, because those are not like terms, you cannot combine these terms. So what we have to do is subtract 45 from both sides. And that gives us 19 is equal to negative 36 cosine of M. Now, because it's multiplication, I can divide. So divided by 36, negative 36 both sides. And I don't have to simplify that because I have negative 19 over 36 is equal to the cosine of M. Well, how do I find an angle? With the inverse trick. So M is going to be equal to the cosine of negative 1, or the inverse cosine of negative 19 over 36. And that is the calculator ready piece. So when I plug that in, I'm going to get that M is equal to 121.9. And that kind of makes sense because M is an obtuse looking angle. Okay? Now remember, it looks like it doesn't prove anything and it's not valid, but you can at least use it as a reference. That's an obtuse looking angle, and we just found an obtuse angle. So far, seems to match. Your turn. Do these next 2 problems. When the video plays again, you'll see the answer. And here are your answers. Now, the first one was fairly simple. Just take the square root of both sides. The second one took a little bit of work. Okay, now notice, I use the calculator for everything, but notice how I still have work. I literally use the calculator for every math important step I have, and yet you guys should be able to still follow every single step I made. I should be able to follow every single step you make. So make sure on your own papers that your work looks like mine. Now, down here, I did end up dividing. I'm going to use different colors so you can see what I'm looking at. If ever you divide, number 1, leave it in the 4th decimal place. If ever you get decimals, leave it in the 4th decimal place while you're working. But also, if ever you have a number is equal to the cosine or sine of theta, tangent, theta, beta, x, y, whatever, it should be a decimal. Remember, sine and cosine will never be greater than positive 1 or less than negative 1. So if ever you're doing these problems and you get a number bigger than 1 or less than negative 1, something went wrong. Go back and check your work. Another type of problem you could get is this one, where it says to solve the triangle. Now, before you get started in the problem, you should always do 2 quick checks. The first check is double check and make sure that it is a triangle. Remember last semester when we talked about whether or not a shape was a triangle? And the rule was the sum of two sides has to be greater than the third. So you should always just look at the sides and make sure that, in this case, we have 12 plus 13. Is that indeed greater than 15? And yes, it is. Okay, but before you get started, double check. You don't want to do an entire page worth of work and then come to find out that it wasn't even a triangle to begin with. The next check you want to see is it a right triangle or not? Because if it's a right triangle, you can do regular trig, you can do special right triangles, you could do Pythagorean theorem. We got a bunch of options for right triangles. But if it's not a right triangle, then the only options you have is law of sines and cosines. So, whenever you're asked to solve for the triangle, two checks. Number one, is it a triangle? Yes or no. And then number two, right triangle, yes or no. Do those first. Now, this triangle over here is in fact a triangle, and it is not a right triangle. So we can go ahead and go for law of sine and cosines. When the instructions say solve the triangle, what they're asking you for is every part they haven't given you, which in this case is all of our angles. So we have all the sides, we don't have all the angles. So we're going to use law of sine and cosine to find all of our angles. And let's get started. First off, I'm going to do, we have to do law of cosines to find angle A. So I'm going to do law of cosines to find angle A, which means we have 15 squared is equal to 13 squared plus 12 squared minus 2 times 13 times 12 cosine of A, because those are related. Now we go ahead and simplify. So 15 squared is 225. 13 squared plus 12 squared is 313 minus 2 times 13 times 12. And that is again 312. No, well, it's not again, just 312. Cosine of A. Now I'm going to subtract. 225 minus 313 is negative 88 is equal to a negative 312 cosine of A. Divide. Which gives us a positive 88 over 312 is equal to the cosine of A. Now I'm going to do inverse, so A is equal to the inverse cosine of 88 over 312, and plugging that in the calculator. Now, if you wanted to go ahead and reduce that to a decimal, that is fine. Just make sure you go out to the fourth decimal place, as always. Now, this ends up being 73.6173. So, the measure of angle A is equal to 73.6173. All right. Now, as much as I love law of sines, I'm not doing, or law of cosines, I'm not doing all that again for the next angle. Instead, I'm going to switch to law of sines because now I have angle A. So what I'm going to do is I'm going to use law of sines to find angle B. So here we go. Sine of 73.6173 divided by 15 is equal to sine of B over 12. Now we cross multiply and try to get sine of B by itself. So 12 sine of all of that is equal to 15 sine of B. Now divide by 15. And yes, I know it's a lot of writing. I'm sighing internally too. But the reason why you do all of your algebraic steps on paper is so that you can easily follow your work. It's very simple to make calculator errors, so having it written down on paper is helpful. Now, I have actually run out of room, so I'm going to go from here into the calculator. I'm going to pause the video while I plug this into the calculator so you don't have to wait on me, but when it plays again, we'll see what B is. All right, I literally did the inverse sign of that entire giant fraction, and I got that the measure of angle B is equal to 50.1316. Now, I love law of sines and cosines, which is the next person, but that's a lot of work to find my last angle. I do, however, know a shortcut, and this shortcut is that you remember that all the angles have to add up to 180. So now I'm just going to add up these two angles and then subtract from 180. So that is 50.1316 plus 73.6173 minus 180. And yes, I did it all in the calculator. And the measure of angle C is equal to 56.251. Now, fortunately, we're not solving math anymore, so we can go ahead and round to the nearest degree like it wants us to. So this turns into 74, this turns into 50, and this turns into 56. I'm going to check that quickly on the calculator just to make sure that those angles do add up to 180, and yes, they do. So these are my answers. Notice how much work I did even when I was using my calculator the whole time. Okay, you still want to show out your algebraic steps. But this is how you solve for the triangle. All right, two problems. The first problem is very similar to the one we just had. So I'm going to leave that for you to do and talk about this next one. In this one, it's very helpful to draw the picture. Again, it wants you to solve the triangle, which means give it everything it doesn't have. But this triangle is different. So A, B, C. We know that B is 1, 1, 9, so clearly not drawn to scale. C is 26. We know that CA is 15. Okay. Now in the previous problem, we were given all the sides, solve for the angles. In this problem, we're given two sides, solve for everything else. Well, two angles and a side, sorry. Finding the third angle is easy. Just add them up and subtract from 180. Whoops. Calculator error. So that means that A is 35. And now, since I have all three angles, there's really no need for me to do law of sine or law of cosines. Because law of cosines' primary function, or the main thing it helps us with, is to solve for a missing angle if we have two or three sides. But now I can just go straight to law of sines because I have a pair. So I'm going to first solve for side A, then solve for side C. If you want to do it the other way, that's totally fine. We should end up in the same spot. Okay, so sine of 119 over 15 is equal to the sine of 35 divided by A. Cross multiply. You do get to a point where you can kind of see where this is going. So if you get to that point, go for it. In the meantime, just go ahead, be patient, and do every step. Okay, and then you can just plug that straight to the calculator. I'm going to pause so you don't have to wait for me to type all that. So side A is 9.8370. And actually, I'm going to go ahead and round this one since I won't be using it on the next one. So side A is about 9.8. Let's round to the 10th spot. Okay. Let's do the next one. Now I'm going to reuse sine of 119 divided by 15. Now the reason why I'll change colors. Now the reason why I'm reusing that one is to guarantee I don't compound a math error. See, if I made a mistake in round 1 and I use that mistake within the problem, then the math errors get worse. However, if you always start off with what they give you, then at the very least you can kind of limit any and all disasters that may occur. And by disasters, I mean math errors. All right, so by now I'm kind of assuming that you know what I'm doing, which is why I'm not explaining every step. If you need me to explain, please ask. But otherwise, I'm just going to keep showing you what to do. Nope, sign. All right, and that's calculator ready, so I'm going to go ahead and plug that in the calculator. I'm going to pause the video so you don't have to wait on me. Now, I forget if the TI does, or I know the TI does it. I forget if Desmos does it. But there is a function on the TI where you can recall the last equation, and that does save you the effort of having to retype everything. Because you can just recall the last equation, and all you're doing is changing one little piece. All right, so that means that C is about 7.5. And those are our answers. We have solved for the entire triangle. All right, and that is the end of our PowerPoint. If you want to do this last triangle, I will put the answers on it. I won't do all of the work, but I'll at least put the answers up so you can double check. Otherwise, if you have any questions, let me know. I'll see you next time. All right, for those of you who are curious, there are the answers to the last problem. They're about 80, 58, and 42. Hope you did well. I'll see you next time, guys.